Hey guys, so I have really missed you guys. I haven't seen you since last year. It's been forever. Just kidding, but I have missed you. Okay, so we are continuing with constant rate of change. We're also going to review a little bit from before Christmas break to make sure that we're all on the same page. And with that, we're going to start by I'm going to remind you what it looks like for a graph to be proportional. So when is a graph proportional? All right. So before Christmas break, we were talking about information being proportional or not proportional. And remember, we were doing D equals RT for distance, rate, and time. And we were also doing y equals kx, which is essentially the same thing. They just use y, k, and x instead of dr and t, where k is your constant of proportionality. And we were looking at all of this, and then we talked about on a graph whether or not, just looking at a graph, can we tell if it's proportional or not? And the answer is yes. So remember, on a graph, if the line passes through the where, I know some of you remember, through the origin, which remember, that's where our x and y cross, that's at point 0, 0, then it is proportional. So that's what we talked about before Christmas break. And so that's what we're going to look at today. And we're just going to be looking at different graphs and deciding, is it proportional, yes or no? So when you're looking at a graph, you are literally looking to see, does it pass through the origin? Now, remember, it has to be a line. It can't be some funky thing. So, like if I were to draw this, okay, that passes through the origin right there. But this is not proportional because it's not a line. It changes the whole way around. So this is, even though it passes through the origin, it's not proportional because it's not linear, which means a line. It is not constant. It changes. It goes down and up and down and up and down and up. So it's not constant. So it is not linear, which means a line. Okay? So even though it crosses through the origin, you have to be careful because it has to still be a line. And that's why right here it says if the line passes through. Okay? This is not a line. So now if I were to come over here, and I were to do this, that is a line. It's constant. It stays the same direction, and it passes through the origin. So yes, it is proportional. Okay, I could do another one. It can go the other direction. It's still constant. It's still a line. It still passes through the origin. It just goes the opposite direction. So both of these are proportional. They're also linear. So both are proportional because they pass through the origin and are constant and linear. Okay? So now we talked about constant of proportionality. Okay? When we start getting into our linear stuff, they start changing that from constant of proportionality or constant rate of change. They call it the slope. And I don't know why they change it, but I have a good idea. With lines, they don't have to be proportional. They're linear, but not necessarily proportional. So you can't use constant of proportionality anymore. But instead of using constant rate of change, which they do sometimes, they change it to slope so that you know you're looking for something that's constant, but it doesn't have to pass through the origin. So they're trying to kind of break away from that idea so that you understand that it can cross anywhere and still be a line. And we'll talk more about that later this week. But that's just kind of my 2 cents worth on that. So like I said, we talked about this before Christmas break. If it passed through the origin, then yes, it is proportional as long as this is a line. So it's constant. This is not. So you just have to be able to look at your different graphs. So now, if I show you, let's see here. I got a couple little papers I want to show you. We're going to do some review tomorrow on constant of proportionality. It's a little coloring activity. You have to figure out what the constant is, and then you get to color based on what you found. So we're going to work on that some tomorrow, just as a review. But if we look, I wanted to pull this out for you. We found the one that has all the graphs on it. Okay, this will work. All right, so if we look right here at this graph, it is constant, it is linear, but it is not proportional because it does not pass through that origin. Okay? So even though it has a constant rate of change or a constant change as it goes up, it's going to go up at the same rate. It's not proportional because it doesn't pass through the origin. That is the big rule. That's what you have to remember. So as soon as I see that this line does not pass through the origin, I don't have to worry about anything else. I can say not proportional and move on. Now, on the other side though, if I see this one, it is a line, it's linear, it's constant, it's going down at the same rate. Right here, it passes through the origin. As soon as I see that it passes through the origin, then I can say, yes, this is proportional. Now, what they might do is they might say, okay, if it is proportional, what is your constant of proportionality? So you got to find that number. So remember, it's y over x. Okay, here we go. So remember, to find the k, we do y divided by x. Now, you can't use 0 divided by 0, okay? That doesn't work. So pick one of these other points that you see it passes through. So like right here, this is an easy one. My point is at 1, -1. Remember, we go x's first, then y's. So we went over 1 and down 1. So 1, -1. Now, all I have to do is take these numbers and put them here. So now, k equals -1 divided by 1. What is -1 divided by 1? -1. So that means my k is -1. My constant of proportionality is -1. So it's really easy to find it on the graph. Okay, you just find one point. You don't need more than one when we're doing this. Just one point for the constant of proportionality. So because it is proportional, it goes through the origin. We know that we are looking at y equals kx. We just found k, so that means that my equation is either -1x, but remember, we don't have to have the 1, or you can just write it as y equals negative x. Okay, notice your line's going down. It starts at the top and it goes down. Anytime you have a line that looks like that, your constant is going to be negative. However, if you have one, looking back at this one, going from the bottom up, it's going to be positive. So think about an elevator. I'm going up, so I'm going in the positive direction. If I look at a graph and my elevator is going down, then it's negative. So that's one way when you're looking at a test, when you're doing a test, you can look at your answer choices and you can determine which ones you can mark out, because if you look at the graph and you know, hey, it's my elevator is going up, my slope's going to be positive, or my constant's going to be positive, then you can mark out anything that has a negative constant. So that is just, quick review. That's what we were doing before Christmas. So we're going to look at some in the guided practice on your Google Slides, just looking at them. Hey, is it proportional? Yes or no? What is the constant? All that good stuff. So let me minus this here. So now I'm going to go right here. So now we're going to look at our guided. We're going to look at these pages right here. So now I'm going to shut this one down. And then I'm going to start a new one, and we're going to be talking about this information on your Google Slides. All right, so click over. I'll see you in a minute.